What is point-free style? And does it have a point? By the end of this episode, you'll know what point-free style is, how you might already be using it, and why it makes things hard to read sometimes. Hi, my name is Eric Normand, and I help people thrive with functional programming. Point-free style it's an important term because you might come across it when you're reading about functional programming or in a discussion with someone who's into functional programming. And so it's good to be familiar with it. It's also an important style for programming because it helps you think at the right level of abstraction. And these things are good to name, right? Like this is where my head is. That said, it's not like once you learn this, you should be doing point-free style everywhere, except maybe as an exercise. It is not like the last style that we should be learning. It's nothing like that. Okay. So what is point-free style? Basically, it means you're programming in a way that you don't need to name your arguments or name any of your intermediate values. So when you define a function, normally you have to name the arguments. Most languages require it, or they make that the really easy way to define a function. Likewise, when you're in the body of the function, you're writing what this function does. Often the easiest way to use the result of calling a function is to save it to a variable and then pass that variable to the next function, use it later in the expression. But point-free style says, can we do without that? Naming is hard. It takes a lot of room. It's like a line per variable, and maybe we don't want to do that. Right. So how do you do this? The easiest example to really hit home is if you were, let's say you're calling map, okay? And you're calling map with something like to uppercase, the function to uppercase. It's a list of strings. You're mapping to uppercase over those strings. Now, one thing you could do is you could define, you're calling map, you're passing in a function. So you're going to define a new function, give it an argument. Maybe you call it S because it's a string. And then you call to uppercase on that string and return it. But why did you wrap to uppercase in a new function? It already is a function, right? So you could just pass that to uppercase function directly. It already takes one argument. It already returns the right value. Why would you wrap it up a lot? I mean, just my personal experience, I see a lot of JavaScript programmers doing this. A lot of JavaScript code seems to unnecessarily wrap functions up in other functions. I don't know why it's common there. I know in some cases you need it because the map passes both the value and the index, and you want to ignore the index. And there's reasons for some of it, but a lot of times it's unnecessary. So removing that extra layer where you have to name the argument and just pass in the function itself, it's a way to achieve point-free style, right? Point-free style has a bunch of little techniques that remove the arguments, remove the need for arguments, like one little step at a time until you got no arguments, right? That's the point-free. But you could have point-less, point-minimal style where you have one or two arguments left, maybe. It seems like a spectrum is what I'm trying to say. It seems like a spectrum. Like you could get down to point-free style, but you could move along in that direction. All right, another one that we've already talked about in a previous episode is function composition. So function composition in the general case is you have two functions. You want to take the return value of one and pass it to the other. So you make a new function, it takes the arguments, passes them to the first function, saves the return value, then calls the second function, and with that return value, and then returns it. Okay. Well, there's a special case where the second function only takes one argument, and it's the return value can go right in there, and so you don't even need to wrap it in a new function that you write explicitly. You can put all that boilerplate into another function, a higher order function that takes two functions and returns a new function. So notice when you do that, you've totally eliminated naming the arguments or the intermediate values. You just say compose fg, right, or f.g, depending on your language and how you do it. So instead of writing new function that takes x, calls g of x, and then passes that to f and returns it, you just write compose fg. You've eliminated the argument. So function composition is used a lot in Pointfree style. Another way that's very related to function composition is pipelining. So if in Clojure you have a thing called the threading macros, it's a bunch of things. It's a bunch of different macros that do threading. And what it lets you do is write pretty long function composition expressions, but in a top-down, like one line at a time way, where the return value of one thing is passed to the next thing, is passed to the next thing, is passed to the next thing. So you never have to name those things. And so this is a way of achieving Pointfree style. I believe Elixir has something very similar. I don't know if they call it threading or pipeline, something like that, but it's the pipe. Oh man, am I going to get this wrong? I think it's pipe greater than sign. Elm has something similar as well. It just lets you flow values through these functions. And so you don't have to name any of those intermediate values. Why would you want to do this? Why? Right? Why is this a thing worth naming? Two reasons, really. Naming is hard. So having to come up with all these variable names is it's a thing that if you can avoid it and without much cost, it might be worth avoiding naming. The names take up more room, so you have longer code. There are things that could get out of sync more easily, or let's say easily, meaning, I've had a thing where I call it I've called the variable 5 days because the first time I wrote it, it was 5 days, like a unit of time. And then I changed it, and now the function that I'm assigning to that variable is returning 7 days, and I need to change the argument name or the variable name. I need to change the variable name and then go and find everywhere I use it and change it. I named it wrong, right? Naming is hard. I named it wrong, but I could have avoided that maybe and not have to deal with it at all. Right. So, but then there's this other more important reason. Besides just not having to do this hard thing called naming, the other thing is that when you're doing Pointfree style, you're often working at a higher level of abstraction, or let's call it the right level of abstraction. So, you're really in the zone. You've got the whole program in your head, and you're thinking, okay, I need to compose these two functions You don't want to be thinking, okay, now I have to define a new function, give it an argument name, and then thread this argument in here. And you don't want to do all that. You want to think, oh, I'm just composing these two. Done. In Haskell, it's one character, dot, f.g, boom, the period, the full stop. So it lets you express yourself at that higher level, just like higher order functions do. It's done with higher order functions. Pointfree style is done with higher order functions, but this is taking it to the extreme where you'd never name arguments, right? That's the style. So it just like you can get into this flow where you've got like really good concentration that day, and you've got the whole thing in your head, and you're working really efficiently and coming up with some very clever code. That doesn't mean that tomorrow you're going to be in that same headspace, or a week from now, or certainly 6 months from now. This style can be very terse, and it relies often on like operator precedence rules and like other knowledge of like how things work, like how currying will work and things like that. So what happens is you come back to it and you don't understand it anymore. Looking at some Haskell point-free code examples, I used to work in Haskell, and I would write stuff like this sometimes. There's like a lot of parentheses around things. So like there'll be a parentheses around the compose operator because you want to force the precedence somehow, or you're passing the compose, and you don't want compose to run, you want to pass compose, so you would put parentheses around it. And so you get some really, what I would consider gnarly code. There's something about the redundancy of names that makes it easier to read sometimes. So I think it's like a noble pursuit, or it's a good exercise to try to push this style to its extreme. Just like in architecture, you might say, let's take some architectural principle and push it to the extreme and see what we get, what building we will design if we just say, we're only going to, I'm just going to make something up, but like all the vertical structure is going to be made of steel, and all the horizontal structure is going to be made of wood, right? So just very, very basic rules and constraints like that. And then you see what buildings you make out of that. It's a great exercise because it's forcing you to explore in this new way. That doesn't mean that it will make a good building. Doesn't mean people will want to live in that building or work in that building. But it's a good exercise. And I think that that's true of point-free style. It's a good exercise. It causes you to think at this higher order function level. But it doesn't mean the code you write is the code you want to live with in your system. That's my opinion there. Someone has said, the guy who wrote the Dart programming language, he has said that he thinks that you really can't do point-free style and currying, which is used in point-free style a lot. You can't really do them without a good type system, because you lose so much information when you eliminate the arguments and the names of the intermediate values, that you really you can't tell yourself when you're looking at the function whether it's correct or not, whether you've made a mistake. Just as an example, if you if you wanted to write a sum function in Pointfree style in Haskell, because Haskell lets you do that, you say sum equals fold R, if you're doing a fold R, plus 0. Okay, that's Pointfree style. I have not named any arguments. Typically, if you're going to do a fold R, you could say sum of the list is equal to fold R plus 0 list, right? You're naming the list argument, but you don't have to because of currying. But now when you read that, you have to know how many arguments fold R takes. You might know it, okay? Like, I'm not saying you don't know that, but what if it was a different function? What if it wasn't fold R? What if it's some other function that you don't know? You don't know, like, if there's some currying going on because you don't know how many arguments that function has. So now you can look at the type, right? But that's it. That's what he's saying, that like it relies on good type information that your compiler can check. So I tend to agree with that. I think that if you go that far, you lose so much information for your brain to pick up on that you really need the help of a type system. Just look at some of the Pointfree style stuff people have done, right? You just have all these like operators, dots, and double, greater than, less than kind of operators, and you're like, what does this do? How many arguments does it take? Like, what's the precedence rules? I can't figure out why you put those parentheses there. It's very terse. That said, I think it's a spectrum, and you can go to this extreme, but also there might be somewhere along that spectrum that is perfect and has very clear code and does not have unnecessary names, but has some names that give you clues about what the code is supposed to do. Another thing about it is, because you're working at this high level, this is a good thing. You're working at this high level, you or the compiler can begin to do algebraic manipulations on the functions. You're at a higher order, so you're dealing with functions of functions. And so these functions can have like algebraic identities, like algebraic properties. Like you could say, just a simple example, that map of f is equivalent to a map of f over a list is equivalent to of the list of f of each element of the list, right? So that's like an identity. And so your compiler might say, oh, because I'm working at a higher order function, I understand how map works. I can replace this map with something else, right? With some other code that it's equivalent to it. I don't have to actually call the function map myself. There's a bunch of these identities, and in fact, that is where the programming language J was going. The idea was that you couldn't define functions with like a defen or a def function. Like, there was no way to just make a function. You had to do it with these higher order combinators. And so you would be able to have all these algebraic identities that would let the compiler optimize and do all sorts of cool stuff. It's like, imagine you could only do map, filter, and reduce and not define new functions. So you're just like mapping and filtering and, with existing functions. And compose, obviously you can do stuff like that, compose. So the languages that use this the most, I mean, this is my experience, my little bit of research has turned these things up. This is where I've encountered it the most. So there's the APL family of languages. APL, famous for being very terse and not having to name arguments. J is a member of the APL family. Look at some APL code and you'll see how terse it can get. Haskell Haskell lets you work on the whole spectrum. You can define all your arguments with names and intermediate values with names, or you can move more toward the Pointfree style if you want. I already mentioned in Clojure and Elixir, there's the like thread or pipeline stuff. And I just want to mention, like, names can be bad, but they can be really good for readability. They can be a pain to write, but really helpful when you're reading your code. Okay, so just to recap, I'm going long, so I'm just going to recap real quick. Point-free style means programming where you don't have to name arguments or intermediate values. And the main reason we do it is to be able to code at the right level of abstraction. That you don't want to be like thinking about how do I name this function or how do I name this argument and stuff like that. You want to be thinking higher order, like, okay, this is the composition of this and this is mapping that over this. That's what you're thinking. And then it creates some really terse code that can be kind of obtuse, hard to understand. APL, family, Haskell, Clojure, and Elixir, those all use it. Right, so I want to ask you, are you using point-free style anywhere in your code? Have you managed to, eliminate an argument here or there that you didn't need to name? And then I'm also curious because there's some really opaque code out there that's in point-free style. I'm wondering what the worst you've seen is, and send that to me. You can email me at eric@lispcast.com, or you can tweet me at Eric Normand. Find me on LinkedIn. And please subscribe if you like this, because there's more coming down the pipe. So I'm Eric Normand. I'll see you later.